A fully charged capacitor has 12 microfarad and 6 millicoulomb charge. Okay, 6 millicoulomb charge. The capacitor has been discharged through 100 ohm resistors. Okay, determine the potential difference across the capacitor, the time constant for charging circuit, time taken if 20% charge left in the circuit in a capacitor, and sketch the current time graph to show discharging process. Okay, good. So first of all, identify, is this charging or discharging process? Which one? Is it charging or discharging? Because different formula, yeah, different formula. So what I can see here, this is a discharging process because it mentioned the capacitor is being discharged through the resistor. It's not connected to battery. Yeah, it's not connected to battery for charging process. Yeah, it's connected to resistor, right? Connected to resistor only. There's no battery inside to charge the capacitor. Okay, so it's discharging process. All right, it's discharging. Okay, discharging process. So we are going to use formula for discharging process. All right, formula for discharging process. We know that okay, maybe I can straight away mention here. We have charging and discharging, charging and discharging. Okay, and then below that we have charge, voltage, current for both. Charge, voltage, current for both. And then we know that for charging process, the charge and voltage will go up, only the current will go down. The discharging process, all will drop, yeah, all will go down. Current always, no matter charging or discharging, current is the only one. Current is the only one will always going down. Understand? And then because of going up and going down, we can determine the formula to use for them. Okay, we can, because of going up or going down, we can know which formula to use. That means what I'm trying to say is going up and going down, we have if going up, we use the formula 1 minus exponent. If going down, we use a formula exponent. Understand? So those who go up, they use 1 minus exponent. Those who go down, those quantity that go down, use exponent. Okay, this is the, what I can say, this is the key to remember everything. Yeah, to remember all the formulas. I hope you remember. Yeah. So okay, this is the key. So this is a discharging process. We are going to use only this formula. Understand? Then because it's a discharging process, we are going to use only this formula, the formula under discharging. So we no need to look at charging process. Understand? No need to look at them. Okay, so right now, what quantity I have? I have a fully charged capacitor. Yeah, it's already being fully charged. So you have charged, so this capacitor can discharge because it's being fully charged. Yeah. So because it's he say is fully charged. So this is the Q naught, the maximum charge, the maximum initial charge. This is the maximum initial charge. Yeah. Millicoulomb, you have to change to SI unit. Yeah, coulomb. And then this one, 12 microfarad is the capacitance. Capacitance of the capacitor, and then you have resistor, discharge through the resistors. Okay, right. So this resistor is 100 ohm. So this is resistance. Okay. All right. So let's do question A. So I want to find the potential difference across the capacitor. That means I need to find what is this potential difference across capacitor. That means this is the capacitor, this is the voltage at 0 second, yeah, at initial. Yeah, he didn't mention what time, isn't it? Didn't mention what time. That means this happened at initial, at 0 second. So this charge also happened at 0 second. Understand? This charge is the initial charge. So we want to find voltage at the 0 second also. So how to find the voltage? Very simple. Use the formula Q equal to CV. But this one is maximum charge, so you will have maximum voltage. Okay, you will have maximum voltage. So this one should be V naught. Yeah, I can say this is V naught. So we're going to find V naught. So maximum charge means has maximum voltage. Okay, substitute. Yeah, substitute. My capacitance is 12 micro. So micro is exponent negative 6. Exponent negative 6 micro farad. And then voltage. Voltage. Yeah, that's what I want to find. The maximum voltage. So the maximum charge is 6 micro. 6 milli, not 6 micro, 6 milli coulomb. Milli is exponent negative 3. Yeah, exponent negative 3. Okay, so I can find my, okay, remember change to SI unit. Milli is exponent negative 3, micro is exponent negative 6. So I can find my maximum voltage. Okay, V naught means V naught and Q naught both means maximum maximum value. It doesn't mean initial value. It's not initial charge and initial voltage. No, it's maximum charge, maximum voltage. That you should think that way. Q naught is actually the maximum value. It's the maximum value, not the initial value. It's the maximum value. Okay. Okay, so let's calculate. Yeah, let's calculate. So 6 exponent negative 3 divided by this 12 exponent negative 6. Okay, so 500 volt. 500 volt. Okay. So 500 volt. So that's correct. My answer 500 volt. Okay, that's the maximum voltage. So now let's do question B. Question B. So I want to find the time constant. Right now I want to find the time constant. So which is tau. Yeah, time constant. So the formula is time constant is RC. Do I have R? Do I have R? Yes, 100 ohm already in SI unit. 100 ohm, no need to change anything. Capacitance is 12 microfarad. Change to SI unit. Capacitance is 12 exponent negative 6 lah. 12 exponent negative 6. Because exponent negative 6 is micro, yeah. All right. Farad, yeah, change to SI unit already. So I get 12 exponent negative 6. Oops, a second. 12 exponent negative 6 multiply 100. So I get 1.2 exponent negative 3 second. Okay, so that's my time. Yeah, 1.2 exponent negative 3 second. Okay, so I got my time. So now okay, let's do, okay, so now let's do question C. Yeah, question C. What is the time taken? What is the time taken if 20% charge left? 20% charge left in the capacitor. So this one is talking about charge. Yeah, talking about charge. So we're going to use, we need to find the time taken T, and he's talking about charge. So what formula we're going to use for this one? Okay, so we are going to use the formula for charge. We're going to use formula for charge under discharging process. So which is under discharging process, the formula for charge, which is this one. We're going to use this one. Understand? Discharging process, using the charge for discharging process, which is decrease, charge decrease in discharging process, which is using exponent, because the charge decrease means use exponent. Okay, so that's how I remember the formula without looking at the list of formula. All right, so okay, so this is a discharging process. I'm going to use formula for charge, which is Q naught. Okay, what to write after this? Because we know for discharging process the charge decrease, so this one we use exponent. If increase, use 1 minus exponent. If decrease, use exponent. Okay, so negative T over RC. All right, so now 20% charge left. Okay, he say what is the time? So that means the question is what is the time, okay, when the charge is 20% left. When the charge is 20% left, that means when the charge is 20% of the maximum initial charge. Understand? So what is the time? You want to know what is the time when the charge is only left 20% out of the maximum charge. So 20% of maximum charge means we can make it into fraction 20 over 100, or we can write it as 0.2 Q naught. So that's our Q. So I can write this over here, I can write this over here. So Q becomes 0.2 Q naught. E over this one is this RC is actually time constant, isn't it? Time constant. So I change it, this one, into time constant. Okay, I change it time constant because I already got the time constant just now, so I don't need to substitute the R and C again. Okay, so so Q is 0.2 because 20% left, right? So 0.2 Q naught. So what is the time? I want to find the time here. So okay, this Q naught can be cut off because they are the common. Okay, and then so this 0.2 equal to exponent negative T over tau first lah. I just write tau. I don't want to write so many numbers because I want to ln. I want to ln both sides first. Yeah, ln both sides. So I ln both sides. I ln both sides. Okay, and then this thing, the top here. Okay, the top here can be carried down, isn't it? When I ln both sides, I can carry down this one to the side, right? So it becomes negative T over tau ln E. Understand? Ln E. So and then another thing is this ln E is equal to 1, and then now I can substitute the value for tau. Okay, okay, ln 0.2 should be equal to negative 1.60944. Okay, negative 1.60944 equal to negative T over tau. What is tau? Tau, the time constant is 1.2 exponent negative 3. Okay, 1.2 exponent -3 second. So that's the time constant. Just put that time constant there. Okay, so next we can find our time already. So this one multiply -1.2. Oops. -1.2 exponent -3. Okay. So what's the answer? The answer is 1.931 exponent -3 second. Okay, that's the time. That's the time when that's the time when the charge become only 20% of the initial charge. Understand? There's the time when that means 20% charge left. Okay, that is the time when the charge becomes 20% of maximum charge left. Okay, so is the answer correct? Yes, 1.93 exponent -3. 1.93 exponent -3. Okay, correct. Yeah, correct. Okay, good. 93 exponent -3. -3 equal second. Okay, good. So now I want to find what's the current, sketch the current time graph to show the discharging process. In fact, okay, let me draw it out. Actually, I have the graph already. Yeah, current decrease, right? Current decrease, discharging process, current decrease. So all right, so let me draw it out for question D. Oops. Okay, so this is the current. Okay, remember to label the unit. Label the unit ampere, and this is one is time, second. Okay, so what's the current? Do I have the current? Do I have the initial current? Do I have the initial current? No, I don't have the initial current. Value. Do I have the current value? No, I don't have the current value. Never mind. Yeah. I don't have the current value. Is that it? Since I don't have the initial current value, I need to find out. Understand how to find out the initial current value? How to find out the initial current value? Okay, so because we have the resistor here, what I can say is, okay, let me draw it out the circuit. Okay, is you know, a capacitor here, and then a resistor. Okay, so because initially we have resistor, we have the capacitor. Capacitor initial voltage of capacitor is okay, initial voltage of capacitor is 500 watt. 500 watt. So they must have okay, they have this is the initial voltage for the capacitor. Okay, I got from here. So when discharging process happen, yeah, discharging process happen. So current, let's say this is a positive plate, this is negative plate. So current will flow. You know that current when this is the initial, we see that this is the maximum voltage. You will also have the maximum current. Maximum current here. Current passing through the resistor. So what I can say is the current, this one also pass through the resistor. So this one VR is also maximum, yeah, is equal to the V naught C lah. Okay. Okay, so we can, that means I can use the formula, what? I can use formula to find the current. So V is equal to, you know, V naught is equal to I naught R. Understand? Because why? Because we have the V naught or V naught C lah. I can write as V naught C. The VR is equal to V naught C or V naught lah, yeah? V naught. So V naught equal to I naught R. So when, as I said, you see, where in initial we have maximum charge, maximum voltage. We also have maximum current. You see that? We also have maximum current. Maximum voltage, we also have maximum current. Okay. Initially it's all maximum value, yeah? Maximum value. So I can find my I naught. I can find my I naught. So my V naught is 500 volt. Yeah, I got just now from here 500 volt. This 500 volt, and then I need to find my I naught. Resistor is 100 ohm. 100 ohm. Okay, 100 ohm. So my I naught is divide, and I got 5 ampere. That's my initial current. Okay, that's my initial current. All right. Okay, so now I can label. I can label my. Wait a second. Change it. Okay, so I can label it with I naught. I naught. So this is my I naught. I naught, my I naught is 5 ampere. Okay, my I naught is 5 ampere. So it will decrease. It will discharging process. Yeah, because we know that for discharging process, current decrease, right? Current decrease. So the current decrease. But not touching the, you know, nearing the axis, but not touching. You cannot cross. You cannot cross like that. Cannot. The graph. This one is wrong. Yeah, graph cannot cross the axis. Okay. Yeah, this one is correct. Yeah, the above one is correct. Nearing only approaching. Yeah, only approaching the axis. Only approaching, or can say the time axis lah. Only approaching the time axis. Because it's an exponential graph. Exponential graph will not cross the axis. Yeah, only approaching the time axis. Yeah, or maybe only touching the, yeah, not even touching the time axis lah. You also can label there. This one. This is the time constant. Yeah. What is the value of time constant you got just now? Time constant is label that 1.2 exponent -3 second. Okay. This is the time when the current become 1 over exponent of the initial value. 1 over exponent of initial value. Maybe you can calculate also. Okay. 1 over exponent of initial value, or 5 divided by exponent. Okay. Is 1 point. So this is over here. This is 1.84 ampere. 1.84 ampere. 1.84 ampere is or this 1 over exponent also can write as 0.37 I naught. Yeah, 0.37 I naught. So all right, is it correct? 0.37 times 5. Yeah, 1.85 or 1.84. So 0.37 also can. You can write also 1 over exponent of initial, because yeah, you should know, you should understand this lah. Okay, 0.37 or 1 over exponent of the maximum current. Okay, calculate, you got this. So the value over here, the value of current, at time constant is actually 1.84 ampere, or 0.37 I naught, or 1 over exponent I naught. Okay, so that's the graph of the current decreasing for discharging process. Okay, current time graph, isn't it? They ask. Okay, so either you draw this, or you want to draw the graph at below the axis also can, because he regard this one as negative current. Yeah, because you know he's comparing between charging and discharging process. When discharging process, the current move in the opposite direction. In the negative direction compared to the charging process. So you can either draw this or you can draw this. Both accepted. Yeah, both accepted for discharging process. If this one, I draw like this because I just ignore the negative sign for current. So it's also acceptable. Yeah, important thing is the shape of graph must show the current decrease, not increase. Yeah, must show the current decrease. So that's all for this question. Yeah, see you in the next video.